Much of what we're going to talk about today is why you need a solution like Spark when it comes to big data, and how this fits with what customers and organizations today are really struggling with when it comes to actually accessing a lot of data at scale and working with a lot of data at scale. So I'm going to give you a little bit of a quick overview of what ClearStory actually focuses on, but to be clear, the purpose of this session is not so much to dig into specifics about what a ClearStory solution is all about, but rather what organizations are really struggling with today and the type of analytics interactivity and speed of analytics that they're looking for that Spark plays a big role in, that we think is going to be very critical when it comes to the big data problem moving forward. So on a quick overview here on ClearStory, so we are specifically focused on solving the problem of converging data from disparate sources, both internal sources, external sources. Your internal sources could be sources like Hadoop, your legacy data warehouse, databases, et cetera, as well as a host of external sources that companies and users want to bring into the mix with their private data to drive what we call a converged insight or a connected insight. This is becoming a bigger and bigger problem as organizations deal with a lot of heterogeneity in their data and are trying to tap into very disparate sources. So what are some of these sources that I'm talking about? When it comes to private data, I think you're all very familiar with what the common sources of data are that they're trying to tap into, including Hadoop-based platforms, such as those from Cloudera, Hortonworks, Adapt, et cetera, as well as pre-existing data that they've housed in their data warehouses, RDBMS systems, as well as cloud-based applications such as Salesforce.com, Google Analytics, and such. So there are a lot of private data sources emerging across organizations. It's created all these islands of data everywhere. And we're at a point right now where organizations are now trying to bring this all together in a more intelligent and smart way so they can actually drive a converged insight. In addition to that, there's another big phenomena happening, which is that there's been an explosion in the amount of public and external data available over the web. And if you look back about 5-6 years, there were less than about 100 open data APIs on the web. And today there are over 8,000 open data APIs. And not all of these are necessarily super high value to Global 2000 companies, but there are many of them that do offer a lot of data that these organizations are trying to tap into that's highly valuable when brought into the context of their own private data. So driving and enabling this convergence or merging these worlds of private data with public and web data is a big phenomena happening out there that we really believe in. The interesting thing is when you look at all of this data out there, especially on the external side, only about 3% of this data is actually tagged, and today about 0.5% of it is actually brought into the kind of analysis that large companies are trying to do. The reason for this is because it's very hard to tap into a lot of those sources, and there's no good way to do it because you have to go to each unique source and figure out all its nuances. So trying to smoothen and address that issue and making all this external data more usable in the context of private data is definitely one of the things that we at ClearStory see as an important factor moving forward when it comes to solving one of the problems in the big data world. But when you try and do all this and bring all this data together, whether it be data from the web, such as clickstream data, social data, et cetera, combined with private data from your RDBMS solutions, Hadoop, CSV files, combined with premium data sources that may contain market intelligence data, survey data, et cetera, or public data that may include things like census data, weather data that's openly available on the web. When you try and pull this all together, not only are you dealing with a lot of data at a large volume, so a lot of scale, but in addition to that, the users inside of most organizations today that are trying to drive this converged analysis have expectations on a platform where they want to be able to see things as they unfold. They want a high degree of interactivity with all this data. They expect basically to be able to get insights very quickly. And that's really where Spark comes in. So really solving the problem on top of big data platforms and bringing more interactivity and low latency processing to this issue so that you can now enable users across organizations to see data when they need to see it faster, and bring a high degree of interactivity around a converged analysis. The type of specific examples that Stephanie is going to talk about, and again, we highlight these couple of examples, there are many, many more, but just to pick on a couple here, the purpose of these particular examples that Stephanie's going to go through is to just, again, shed light on what are companies trying to do and what are the type of demands that they have on big data platforms today that require solutions like Spark and Shark, and how Matei and team at the AMP Lab have been addressing this and what they are building and what they're working on that we think is going to be very critical moving forward. So firstly, when you look at multi-source analysis, as I talked about a second ago, and you bring data in from many different sources, customers expect to be able to actually interact with this in a very fast, low latency type of manner, because they want to be able to answer questions at the right time and sometimes in near real time. So a high degree of interactivity, low latency processing, near real time type of answers across multi-source insights is very important. The second big area that comes up a lot is this notion of live situational analysis, which means that as events are happening out there and you're tapping into data from multiple sources, you want to be able to see insights as they unfold. So literally being able to let business users see insights as they happen and as data starts entering the environment from multiple sources. So that's what we sometimes call live situational analysis. There are many other terms for this, but the most interesting point here is the speed and the level of interactivity that people expect when they're doing this type of analysis. And then finally, some level of automated analytics, or almost self-learning analytics, where you bring together data from many sources and you start understanding basically some of the aspects of the data from these sources and learn as you go along the type of trends that to look for. To some extent, it gets into some level of predictive analytics as well, but really being able to automate the notion of being able to see trends as they're happening. So these are like three examples that Stephanie will, give you some details around each of these, but the main point is there are many, many examples out there of the type of big data analytics that companies are trying to do, that they're trying to do this year, next year, et cetera, that are very critical to how Spark and Shark actually address this problem. So we believe that MapReduce, being a great framework on top of Hadoop, has its purpose in the big data world. It's great for batch processing. It's great for many other type of analytics. But when it comes to the type of analytics that require near real-time answers, high degree of interactivity, and low latency processing, we believe that technologies like Spark and Shark are going to play a very important role moving forward. And that's what Matei is here to talk about today. And as it relates to ClearStory, we believe that this basically becomes one interesting way to solve this problem that Stephanie is just about to detail. So with that, I'll turn it over to her, and Matei will then take it from there.
Thanks, Sharmila. So I'm going to take us through examples that we've seen in the market with customers that we're working with in each of these three different areas, just to give you a quick flavor of what are some of the hands-on use cases that individuals are using Spark to address. So the first is interactive multi-source analysis. And this has really applicability to any organization that is focused on outperforming their competition. They need to really understand their market position and the competitive landscape. And what you see today in most organizations is that they've built put a lot of effort into building a very good store for information typically already in the form of a data warehouse or a data mart or maybe even a Hadoop instance. And most companies are typically storing some of their sales data for analytics. I make a comparison of that type of an investment to making your first investment in your first stereo system, which is a mono speaker system. So you're getting some advantage out of the analytics, but it has a single channel of stereo that's providing to you. And other organizations, to give them credit, have gone out and added to that data warehouse or that single source of truth of analytics in their organization a second source or channel of data. So they've gone into the two-channel realm of the stereo system. And often organizations from a business perspective are looking at that second source of data being a premium source of data. So this might be an Axiom or a Dun & Bradstreet or Nielsen, depending on the industry that you're in. Now with two-channel systems, if you have a stereo system, you may love it in your home, a two-channel stereo system. But a lot of us want to move up to surround sound, and that's kind of the ultimate goal, especially for maybe movie watching or if you're a television fan. And so the question is, why have these organizations not moved into surround sound, and what does surround sound really look like? Well, one of the first barriers before the advent of Hadoop was that a lot of the data outside of corporate sales data and premium data is web data. And so the first challenge is those data sources like Twitter, like Facebook, even something like a weather feed may be unstructured in format, hard to process, and I think maybe even more interestingly, the business value of that data is fairly unknown in advance. So you need some type of analytics to tease out what's important in that data to justify bringing it into a system. And so what slide is not building here. What we see happening is organizations who want to move to that next level of surround sound and add in all of those web sources of data and make that very interactive, struggling with getting there in the market today in terms of being able to have multi-source analysis and also have an interactive platform. So this particular customer, if you put yourselves in the shoes of a movie studio, I've kind of mapped out how these sources of data might help a movie studio get to business value with these interactive sources. And if you think about it, take yourself back to maybe 2008. I don't know any of you who are fans of the movie Iron Man or The Dark Knight. If you remember, both of those movies came to market in the same summer blockbuster year at the same time. And movie studios put a lot of effort into predicting box office opening weekends. Opening weekend, it's hard to make an accurate prediction, but a lot of movie studios are placing their bets on how large opening weekend can be. And in the last 6 to 7 weeks of the ramp up to that movie release, are looking for signals to the market as to how to adapt their release. That requires behavioral information from consumers, and one of the best sources is the web. So if you think about in that industry how this type of multi-source analysis would play out, their stereo system is being able to listen to everything that's going on in social media channels like Twitter and Facebook and their own website and adapt their marketing strategies as they move forward. And there's actually some interesting articles if you look back, and I can share them with folks in the audience that look at how The Dark Knight and Iron Man were marketed differently, even though they had very similar storylines, were hitting a very similar target audience at the exact same summer blockbuster year. So the second example, if I can get to it here. Here it builds out. All right. The other data source I had here in the movie example was public data feeds from web sources like Rotten Tomatoes. So many of you may not know this, but Rotten Tomatoes API actually gives crowdsource ratings information as well as critic information. They start feeding out how individuals are scoring movies about a month in advance. So that becomes another critical source. In this case, we see APIs in many different industries for that type of public data becoming relevant as well in today's new diverse data world. The second example I have here is what Sharmila mentioned as live situational analysis. And live situational analysis is really focused on being able to observe what's happening and catch an emerging trend as it's evolving, because you may have a chance to take action and to influence that trend as it's evolving. And so how many folks in the crowd watched the Super Bowl this year, Super Bowl 47? Not too many. Some of you must not be raising your hands. Come on, guys. So what was the most exciting event? Even if you didn't watch it, you probably know what the most exciting event of the Super Bowl was this year. Power outage, the blackout. So the blackout for Super Bowl 47 was Super Bowl 47's wardrobe malfunction, right? If you guys remember that from a couple of years ago. No one really, to some extent, really cared what was going on with the game. Everyone was interested in what happened during the blackout and how did different organizations respond. Now, if you were an advertiser for the Super Bowl, you had paid in advance of the event somewhere between $3 million and $4 million for your 30-second spot. One particular company that did that was Oreo. And if you were using live situational analysis, if Oreo was using live situational analysis, they would be watching that spot as it came on in the first quarter, I believe, of the game, and evaluating how that television spot was affecting traffic on your website. You might be looking at media rankings after the fact as to how Nielsen was rating the impact of your commercial. But when the power outage happened, individuals who had live situational analysis were able to respond. So what Oreo did immediately, within 10 minutes of the power outage starting, was they posted this beautiful ad on Twitter. They had a social media team that was monitoring in a live situational awareness situation what was happening as the power went out, and a huge mass of people started tweeting about the power outage. So they took advantage of that moment in time. They posted this advertisement that was very visual that said you can even dunk in the dark. Nice play on words there. And that got not only 16,000 retweets at the point of posting, but it also got them on the front page of many journals. There was a Harvard Business Review article that was written about how smart their marketers were. And what was the cost of responding in real time? The cost estimated for this ad was about $40K. So $4 million versus $40K, I think that's an interesting investment to be made in analytics. The last example we want to share before passing over to Matej is one of more automated analytics. And this is a space that's really exciting because it's where the technology actually begins to inform the business user of decisions to be made. And so one of the examples here is looking at how data can be brought into a system in near real time, and the modeling of that data automated so that differences in time or geography between multiple sources can be harmonized. So if you think about something like sales data, I may collect my sales data on a monthly basis. I might want to join that sales data to market penetration data. Now that market penetration data may come in every 2 weeks, or it may be an outsourced firm that only collects that data during a survey period, and so it might be unpredictable. And so the harmonization of those, that time is very challenging to do manually, but systems today are now able to automate that process with some of the new technology that we have. And the other important aspect of this use case is the ability to then apply on top of that harmonized data more advanced algorithms, machine learning, et cetera. So if I'm someone who's looking at the penetration of my product in a market and trying to respond to that, I also ultimately want the system to actually look at customer behavior and begin to suggest different clusters of customers that may be good targets for the product, or attributes of those customers that may indicate a way to change my product or market it better, et cetera. And so the ability to apply things like even simple k-means analysis, which comes kind of out of the box with a Spark technology, is critical. So we've talked a lot today about challenges. Hopefully Matej will give us some insights today on specifics of how to address those and why we think this technology is a very exciting one. We've talked about how to converge data from diverse sources, how to process that data really at scale, not only for human insight, but then more machine-generated insight, and making this process very valuable and interactive for business users. And business users defined as individuals who don't have a coding background, who don't know how to write Python or Java, or your favorite, even SQL sometimes, language of choice. So we're excited about transforming. What's happened in the last 30 years is we had a great transformation as everyone moved towards data warehousing, technology stack, and infrastructure. We're very excited about the future, which means transforming the approach to analytics, not just through the technology, but how we use analytics and data in our daily jobs. And we believe this means moving from batch analysis to interactive analysis at scale, really enabling the business person, not just the data scientist, to hypothesis test and have more hypothesis-driven exploration experience, and to converge data from anywhere, whether that's an API or a standard relational database or another unstructured format. So with that, Matej, I'll hand over to you.
Okay, cool. Yeah, so I'm going to talk about two software projects out of Berkeley that are designed to address these oncoming needs for data analysis, called SPARC and Shark. Let me see if this is, what did, I see, I guess the keyboard is not quite, okay, got it, that's fine, that's just, okay. Okay, so yeah, so as Sharmila and Stephanie pointed out, modern data analysis, to really take advantage of all the sources that are out there, it requires integrating multiple sources of data, many of which are unstructured. It requires dealing with these in real time, because that's how they arrive, and it requires reacting to things that happen quickly. So MapReduce is a very successful technology over the past 5 or 6 years that started to address this kind of need. And what MapReduce really added is a way to do batch processing on unstructured data. It was very easy and actually very low cost to do. And that was great. But MapReduce is fundamentally a batch model with latencies anywhere from tens of minutes to hours, and it can't deal with these kinds of emerging workloads. So we at Berkeley saw we talked with a lot of people who used MapReduce, and we saw in particular 3 needs that they quickly had once they got started with it. One of them was for more interactive queries. It's very clear why interactive queries help you explore data better. The second one was for more complex algorithms they wanted to run. So in particular, Sharmila and Stephanie mentioned you might want to do things like machine learning or statistical clustering algorithms. And these are often multipass algorithms that don't fit well into the MapReduce model. And the final thing is, of course, more real-time processing. So yeah, let me sorry about that. Yeah, so at Berkeley we are we have set up this research project called the Berkeley Data Analytics Stack, and our goal is to actually design a unified stack to tackle all 3 of these emerging workloads. So that's what we think people will need in the future from data analytics, and this is what we think future analytics applications will look like. And this is part of the AmpLab project. This is a 6-year research project started a year ago, and it's supported by fairly big grants from DARPA and the NSF, as well as 18 companies. And we're building a whole bunch of components in the stack, from resource management in the Mesos project to different kinds of execution engines. In this talk, I'm going to talk about SPARC and Shark, which are 2 of the execution engines that we're building. So just really quickly, what is SPARC? SPARC is a fast MapReduce-like engine that extends MapReduce to do a bunch of new things that you can't do with the current implementations. So one of the ways it extends it is with in-memory storage and computation, which is important whenever you're making many queries on the same data repeatedly, and it can really make a huge difference in performance. The second way is that it extends it is with more general execution graphs than just the one-stage map and reduce model that you get with Hadoop. And together, these optimizations let SPARC run up to 100 times faster in real applications with the in-memory data, and in fact 2 to 10 times faster even with on-disk data, depending on the program. At the same time, Spark is designed to be compatible with Hadoop, and it's compatible with all the storage APIs you have in Hadoop. So essentially, any storage system you can plug into Hadoop, we use the same interface that Hadoop has called input format to talk to it, and so you can read that data in Spark. And Spark recently, like basically just today, also adds support for stream processing. So this is something that's still in an alpha state, but it's something we're very excited about because in the same engine, you can now do stream processing, interactive, and batch. What is Shark? Shark is our implementation of SQL on top of Spark, and it's basically a port of Apache Hive. So we, unlike folks who are building a new SQL engine from the ground up, we actually took Hive and made it faster by running it on Spark and doing a whole bunch of optimizations inside. And what's nice about this is that it's highly compatible with Hive itself. You can use it on existing Hive data. If you have a Hive warehouse, you can connect to it, and you can run your existing queries, user-defined functions, and so on, and get these benefits. And it inherits Spark's sort of execution benefits of running up to 100 times faster. So these are both open source projects. Spark actually started as a research project about 3 years ago, and Shark was released last spring. So they started as research projects, but in the past few years, they've also seen quite a bit of use and contributions from industry. So there are now multiple companies that are using these in production, and even more companies that are sort of playing around with them or using them on the back end for internal analytics. And to give you a sense of the community, we have 500 members who come to our San Francisco area meetups, and we have 14 companies who've contributed code to the project in the past year. So in this talk, I'm going to give you a quick overview of both of these technologies, and you can find out more about them after. But let me begin with Spark. So what does Spark provide? So Spark itself gives you a bunch of APIs, high-level APIs, to do data processing in Scala, Java, and Python. And you can also use it interactively from the Scala and Python shells. So the same way you use Python, on your local machine, type stuff in and work with data, you can actually do that to work with a cluster from Spark. And the key idea in there is you get to manipulate these distributed collections called resilient distributed data sets, or RDDs, and you get a whole array of parallel operations to run on them. Just as an example of something you could type in, this is going to be some Scala code you can type into the Spark shell to do log mining. And the story here is, you have a bunch of log files, say, in the Hadoop file system, and maybe something is going wrong with your application, and you want to interactively search for patterns and understand what's going on in this big application. So in Spark, you can load the data by just calling, for example, text file and passing an HDFS URL. And this gives you an array. It gives you a distributed collection of strings, one per line of the file. And this is the base RDD, or distributed data set, that we're going to process. And once you do this, you can do what's called transformations on it. So for example, we can filter out the lines that start with error. This is the code in orange there is the Scala code for a function literal. It's like a lambda in Python. And in fact, in Python, you can just pass a lambda function in there. But you can put any code you want in there, call into libraries, and so on. And this gives us a transformed RDD. It's the lines of text that start with error. You might do more transformations on it. For example, here we're going to split each line by tabs and pull out field number 2, which might be the actual message in the log entry. And finally, you can choose which data to keep in memory. So when you call cache, it says keep only the error messages in memory. Now, once you've done that, you can run a bunch of queries on it. So for example, here, this is the code to search how many lines contain foo. And when you call this, count is called an action. Count is something that actually kicks off a job on the cluster and gives you back a result. And what Spark will do here is it will automatically come up with an execution plan for this query that's efficient. So in this case, it's going to look at where the data is sitting on the cluster and send tasks based on data locality, much like MapReduce would. Each node's going to process it, send some results back, and then each node is also going to build up a cache of partitions of data it's built along the way. So next time you query this data set now, say, foo wasn't the problem, you search for bar, you can get back the answer much faster because Spark will know that the data is in the cache and just hit that and give you back the results. To give you a sense of the impact this makes, I'm going to talk about 2 results. So one of the things we do kind of as a demo is full text search of Wikipedia. Wikipedia is about 60 gigabytes of data. It's not huge, but it's not a thing you can easily deal with on one machine. And so on a 20-node EC2 cluster, if you just try to do a full text search with Hadoop or with on-disk data, it takes 20 or 30 seconds. If you do it with Spark, you can do the same search in half a second. So it's just brute force search of this whole data set. And this, making this interactive really changes the types of questions you can ask about it. And to show that you can do larger data sets too, we've also done 1 terabyte data set on 100 nodes, and you can do a full text search in about 5 seconds. And again, this is a thing that would take minutes with on-disk data. So that's kind of a crash course in Spark. I'm not going to talk too much more about how you program with it, but you'll be able to see it online. I do want to mention, though, that if the Scala thing is a little scary, we also have pretty nice APIs in Java and just released today in Python. So in Java, you can just pass in your functions as classes, and it's still quite a bit more concise than if you try to do this in Hadoop MapReduce. And in Python, you can pass in lambdas or local functions, and we do the same trick as in Scala of automatically shipping that code to the cluster. So we're very excited to have people use it in these 2 languages as well. The other thing I want to mention about the model is that it does provide full fault tolerance. Any set of the worker nodes can go down and the computation will recover. And the trick that it does there is this idea called lineage, which is that Spark will remember how each data set was built and automatically recompute chunks that go missing. So for example, in the example we had before, if we lost one of the caches on a node and we lost the map and filter results, it would actually run that map and filter function again. So that's kind of what the engine does. Apart from doing interactive queries, the engine is also a much better fit for any kind of iterative multipass algorithm you might have. And that's actually what a lot of people have been using it for. So if you have machine learning algorithms, things like logistic regression or k-means clustering are a perfect example of something that goes over the data multiple times. And that's a thing that platforms like MapReduce don't have any support for. You have to run many different MapReduce jobs that each redo a lot of work in Hadoop. Using Spark, you can run these anywhere between 100 and sort of 30 times faster. And even algorithms like PageRank that are quite a bit more communication intensive actually go faster with Spark as well because of the ability to keep data in memory. So this is actually one of the things that a lot of people have been using it for. And just to give you a sense of application, some of the companies that have talked about what they're doing, so people use it for just standard sort of SQL analytics and reporting. They use it for anomaly detection. Quantifine's a company that does predictive analytics precisely on the kind of social media streams that Sharmila was talking about. There's a group at Yahoo exploring it for business intelligence, and there are a bunch of research projects at Berkeley as well. So that's kind of a very quick intro to Spark. I also wanted to talk a little bit about Shark. So Shark is our engine to do SQL, and we're very excited about it because it really opens up this kind of performance to a much wider array of users. So the way we started is we thought Apache Hive is a great platform. It's highly successful and it's very widely deployed. But because it's running on the Hadoop engine, it takes minutes to do even short queries. It's not exactly interactive. So our approach was to actually extend Hive to run it on Spark. If you want to see what's done on the technical side behind this is basically what we did. So when you look at Hive today, it's nicely structured into, there's a meta store which actually handles the catalog of data in your system, and then a client that actually gets your SQL query, comes up with a plan, and submits it to a MapReduce execution engine. In Shark, we only change the client and the execution engine. So it works with the same storage system and same metastore as before. And basically, we update the query optimizer and planner to deal with to use the Spark engine, and we add this cache manager to use memory. But the nice thing is it reuses a ton of the things in Hive that give you compatibility with it. And on top of just kind of substituting a box in there with another box, we've actually taken on a whole bunch of optimizations in the engine that help significantly. So one of the things we do is column-oriented storage and compression, which can lead to dramatic speedups as well as space saving. So you might use actually less space in memory than with your on-disk format in Hive. We do statistics on partitions to do smarter pruning. We pick algorithms like joins based on what happens at query runtime. And we also support co-partitioning of tables that can speed up operations on them. So to use Shark, essentially, you just use HiveQL, and you use the special syntax to create tables that are in memory. So all you have to do is create an in-memory table and then just run queries against it. And I don't have a ton of time for this, but I do want to show you some results. Just to evaluate the system, we actually took, if you remember, a while back, there was this big article in the database community comparing the performance of Hadoop against analytic databases, things like Vertica, where they said, oh, look, Hadoop can be 100 times slower than that. So we said, OK, what if we compare Hadoop against Shark? And essentially what we found is Shark, both with on-disk and in-memory data, has significant speedups and actually starts to approach the speed you see from these very expensive database systems. So this is a really simple select query where it's going about 100 times faster. This is a group by where it's going, I think, about 20 times faster. And even on complex queries with multiple joins and things like that, we have a significant speed up because of the more general execution engine, even if the data is sitting on disk. So that's, I don't have a ton of time to go into it, but it's something we're excited about. And user queries that people have tried see the same thing. So it's not just these benchmark queries. Actual user queries also go significantly faster. So final thing I want to end with is what we're doing next. So we've talked so far about interactive and complex analytics, machine learning. There are two other things that are really exciting that are coming up. So one of them is stream processing. We just released the alpha version of this today called SPARC Streaming. And SPARC Streaming gives you a fault-tolerant, exactly one stream processing with a really nice API, similar to the one I showed for Spark, and with actually really high performance, so higher performance than engines like Storm that don't provide fault tolerance. And this is due to a new way of doing fault tolerance for stream processing that we have developed. So you can look at that online. And the other thing is just higher level libraries. So we have a bunch of exciting things in the pipeline that build up on the Berkeley data analytics stack, including graph processing, approximate queries based on sampling, and a library of machine learning algorithms called MLBase. And you can look to see these over the next few years. So I hope that's given you a bit of an introduction to these systems. Just to say, Spark, Shark are all open source, and they're being used at a bunch of companies. We've tried to make them very easy to deploy, and we'd love to get more users or contributors to them. They are designed to be highly compatible with the Hadoop ecosystem, and if you want to learn them, there are documentations, tutorials. There's actually even a set of video tutorials and online exercises you can do on our website. And I'd be glad to chat after with any people interested in learning about them as well. So that's it. Thanks.